In this video, we will see about the conventional speed control techniques for DC motor and the Leonard method of speed control. So these conventional methods have some limitations. So now we are using converter fed DC drives. So we will see the importance of converter fed DC drives. So what is a DC motor? So basically it is a rotating machine that converts electrical energy to mechanical energy. So we have to give electrical input and you will get a mechanical output. A DC motor has an armature, field, and you need to give the supply. So these three things are important in DC motor. So based on this field connection, it is classified into different types. There are basically two types of DC motor, separately excited and self-excited. Separately excited means the field winding will be given a different power supply. So the armature will be given a supply, field will be given another supply. Then it is called separately excited. Self-excited means the armature itself will be supplying the field. There is no separate supply for the field. Then we call it as self-excited. So depending upon how this field winding is connected to the armature, this self-excited DC motor is classified into three types. Shunt motor. Shunt means it is parallel to the armature. Series means field winding is connected in series with the armature. Compound motor means you have two field winding. One will be connected in series with the armature and another one in parallel, that is compound motor. Let us see the conventional methods of speed control in DC motor. So you have to remember two equations. First thing, N, that is the speed of a DC motor, is directly proportional to the armature voltage and inversely proportional to the flux. So based on this equation, we have different speed control techniques. That is, either we can change this armature voltage and control the speed, which is called armature voltage control method, or you can change the flux and vary the speed. So that technique is called flux control method. Another equation you have to remember is torque is directly proportional into flux into armature current. So these two equations, if you remember, you can study the speed control of DC motor. But if you want to know how you are getting this relation, just go through this equations or derivation. You will understand how you are getting this relation. So we know in a DC motor, back EMF is given by 5Zn by 60 into P by A, where Z is the number of armature conductors, P number of poles, and A is number of parallel path. So all these terms are constant except flux and speed. So I can write it as K, that is all constant sum up together as K, and remaining quantities are flux and speed. So you are getting this relation. Now we know back EMF is equal to V minus IA RA. So equate these two equations, you can find the relation for the speed and flux. Now IA, you have V minus IA RA. Actually this IA is decided by the load. So in general you can write it as N is directly proportional to V by phi. So if you want to know how you are getting this relation, go through this, otherwise you can skip this. Remember these two formulas alone. So in first method, armature voltage control method, we are changing the armature voltage and varying the speed. So armature voltage we have to change while keeping the flux constant. So how to change the armature voltage? So you take the DC motor, put a resistor in series with the armature. So by this way what you are doing, you are dropping some of the voltage here, so that the voltage applied to the armature reduces. So if voltage applied to armature reduces, speed will reduce. So this is how speed control is achieved in armature voltage control method. And we have this relation, torque is directly proportional to flux into Ia. Here flux is kept constant, so torque will be directly proportional to armature current. There are some limitations for this method. Here we have a resistor connected in series with the armature. So as the voltage drops here, a part of the supply voltage is dropped here. So it is an inefficient method. Moreover, since only a part of the supply voltage we can apply to the motor, only speed below rated speed you can achieve. That is, if your rated speed is 1500, you can run at either 800 or 900 or some speed less than the rated speed. You cannot go beyond the rated speed. So that is the drawback of this method. Next you have flux control method. Here as I told, we are changing the flux while V remains same. So here in flux or field winding, you should connect a resistor and you are controlling the field current. Field current is responsible or it is proportional to the flux. So you are controlling the flux here. So as the flux decreases, if you change the flux or if you decrease the flux, the speed will increase. And here torque is directly proportional to phi into Ia. Here you are decreasing the flux, so torque will decrease with increase in speed. So when you decrease the flux, the torque will decrease. This method can be applied only for speed above the rated speed. That is, when you go for flux control method, that is, as you reduce the flux only, speed will increase. So you can achieve only above rated speed. But at high speed what will happen? Commutation problem may occur. So normally flux control method will not be used for wide range of applications. So next we have Leonard method. Here you can achieve both speed control above and below the rated speed or base speed. So for that you need three machines. Suppose you take this diagram, you have a motor, this M is the motor for which you want to do the speed control. That is, I want to control the speed of this motor M. So to achieve, you can do both field control as well as armature control. So to achieve field control, you can easily vary the field current and control the motor speed. That is not a problem. But to achieve armature control, what you have to do is, you have to vary this voltage. So how to vary this voltage? You can use a generator here. So this, you vary the generator voltage so that the voltage applied to the motor will change. So motor speed will change. So this generator will give you electrical output, but it needs mechanical input. So it should be connected to a prime mover. This prime mover can be an induction motor which is connected to a 3-phase AC supply. So this induction motor will drive the generator. So this generator will give you the electrical output which will supply the motor. So by varying the field current of this generator, you can vary the speed of the motor. So for below base speed, that is armature control voltage control method, you have to vary the field current of the DC generator. For above base speed, it is easy, you change the field current of the motor itself. You can also reverse the direction of the rotation by changing the field connections of the generator. So when you see the drives, this diagram is very important. That is, the plot between torque versus speed or power versus speed is important. Here, this Leonard drive, we have seen that you can achieve both speed control below base speed as well as above base speed. So below base speed, it is armature voltage control method. Above base speed, it is flux control method. So you see here in armature control method, the torque remains constant and power will be increasing linearly. In field control method, the power will be constant and torque will be decreasing. So this we will see how it is coming. That is below base speed, torque formula is given by flux into Ia. So we have seen that flux remains constant. In armature control method, we are keeping the flux constant and Ia will also be constant if load torque is constant. So torque will be constant in the armature control method. But if you see the power, the formula for power is torque into speed. So torque is constant, T is constant here, but speed is here. Speed, what is happening? It is increasing like this. So there is a linear increase in speed. So P will be increasing linearly. And if you see above base speed, that is in flux control method, we are varying the flux. Okay. So when you are varying the flux, torque will decrease, or you are decreasing the flux so that speed will increase. So if flux decreases, torque decreases. So here torque decreases, but this speed is increasing. Okay, you move from this point to this point, your speed is increasing, whereas your torque is decreasing. So power will be compensated. One term is decreasing, speed is increasing, torque is decreasing. So totally net, the power will be constant. So power will be constant. So you have to remember this diagram. So here torque, if you draw torque, it should be constant first, then decreases. Power will be linearly increasing and then constant. So this diagram is important. So there are limitations for this Leonard method also. So advantage is that you can achieve both forward and reverse speed, and wide range of speed control is possible. But the disadvantage is that high initial cost, because you need 3 machines here, and the efficiency will be low because at all stages there will be losses, and you need more space, and 3 machines will lead to noisy operation and it needs maintenance also. So these are some of the drawbacks of conventional speed control methods. So you can see here, till now rheostat and machines are used to control the speed. But in converters, or after the invention of power electronics, these drawbacks are overcome. So we will see about converter fed drives. So what do you mean by that converter fed drives? Here power electronic converters, instead of rheostats, power electronic converters are used to control the operation of the motor. So what are the power electronic converters? Rectifier and chopper. So they give DC output, so they are used for DC drives. Inverter, cycloconverter, AC voltage converter, all these things can be used for AC drives. So this is the basic block diagram of a converter for DC drive system. That is, if you have a DC motor, you put a power converter here. So this converter will supply the required DC voltage for the machine, and this converter needs electrical supply which can be AC or DC. So this power converter can be a phase control rectifier or a chopper. Now we will see what is solid state speed control of DC motor. You remember, whenever there is a word solid state, it means that power electronics is used or power semiconductor switches are used. We call it as solid state. So earlier we have seen that we put a resistor in series with the armature to achieve armature voltage control method. But when you have a power electronic converter, you can replace this rheostat by a power converter. See here what this resistor is doing. It is the total voltage is here. A part of the voltage is dropped here and part is supplied here. That is, if you have 100 volts, 20 volts I will drop it here across the resistor and 80 volts I will apply across the armature. So speed will reduce. Here same thing I am doing. Total supply voltage is here. I will change the firing angle of the thyristor so that my average voltage here will be 80 volt, so that the motor speed reduces. Okay, so this power converter will do the same function of a rheostat. Here in phase control rectifier we can vary the output voltage by varying the firing angle. So these converters convert the constant AC voltage to variable DC voltage. So phase control rectifiers are of different types: single phase rectifier, three phase rectifier and dual converter fed rectifier. See, for studying drives, solid state drives, power electronics, knowledge on power electronics is very essential. So if you have any doubts or if you want to refresh power electronics, you can go to this channel, Read Electric Vehicle channel. In playlist you can see power electronics made easy. All topics are covered. You can refer to the topics and then come to study this one. It will be very easy. Okay. So single phase rectifier, three phase rectifier, dual converter, fed rectifier. In single phase also you have half controlled, fully controlled rectifier. And with these converters we are able to achieve 1 quadrant operation, 2 quadrant operation or 4 quadrant operation. So what are the 4 quadrants? So first, second, third and fourth quadrant. So you can achieve forward motoring, forward braking, reverse braking and reverse motoring. So all 4 operations you can achieve with the power electronic converters. So in single phase fully controlled rectifier, if you see the diagram, you draw the same diagram what you have studied in power electronics. So fully controlled means all the devices are thyristors. If it is half controlled means you have 2 thyristor and 2 diode. In some cases we will be using freewheeling diode. Okay. So that alone you mark it. Then you take RLE load. So same analysis will be applicable for drives also. Okay. So if you are good in power electronics, drives is very easy. So phase control rectifiers, you have some advantages, like they are very simple, you get fast response, high efficiency and small size. But there are disadvantages also. Major disadvantage is that they introduce harmonics into the supply system. That is, whenever you have power electronics devices, you can immediately write the disadvantage as they introduce harmonics into the supply system. Whatever converter is there, any power electronic component is there, means your disadvantage, first disadvantage should be they introduce harmonics. Next, high ripple content in the converter will increase the heat. Then they have low overload capacity. That is, if you overload it, device will get heated and it will get damaged. Okay. Almost for any power electronic converter, you can write these disadvantages. So the points to remember here are, in conventional method of speed control, it is an inefficient method because part of the voltage will be dropped across the rheostat, and for a change in load, the change in speed will be very large. And if you take up a Leonard system, it needs 3 machines, which will increase the initial cost and also increases the losses. So we can go for converter fed drives, where power electronic converters are used to control the machines. They are highly efficient, simple and give you fast response, but the major drawback is that they introduce harmonics into the supply system. And if you like the video, do subscribe to Read Electric Vehicle channel. And these are some of the references which I have used for this particular video.